We're continuing our study of business applications with calculus. So our learning goal in this lesson, this is 2.62, the third part, is to be able to maximize the revenue and the profit, and then also to be able to minimize the average cost. And that's what businesses do. They want to maximize their revenue, maximize their profit, they want to minimize their cost. Just a little review on the notation. Remember, X is the number of units that we produce or sell. The lowercase p is the price per unit. That always has to be based on your demand. We can't charge $1,000 for a Coke. R is the total revenue from selling X units. And that's always just going to be the price we sell it for times the number of items that we sell. C is the total cost of producing X units, so that the average cost for one unit would be that total cost divided by however many of those items we're selling. P is our profit, and that's always going to be the revenue minus the cost. The revenue again is that XP, that number of items times the price, and then the break-even point is when R equals C. We talked about marginals, how the derivative of the revenue function tells us the extra revenue from one additional unit. Marginal cost, same thing, except with cost. Profit, same thing, except for with profit. Now, this should make sense to you. It says to find the maximum revenue, set the RDT equal to 0 itself. Here's the reason why. Our revenue, it might go up, and then it starts going down again. And it could even come back up again like this. Well, and then maybe it levels off. You never know what's going to happen. So right here, where that high point is, can you see how the slope or the rate of change is 0? The problem is that it also happens down here. That rate of change right there is also 0. So we have to be careful with this. We talked about in sections 3.1 and 3.2 that when that slope changes from positive to negative, we have a maximum. And when that slope changes from negative to positive, we have a minimum. So that's something we have to look out for on maximum revenue and maximum profit. Now, to minimize our cost, we want to find that low point, but that's still going to be wherever that derivative of that cost with respect to X is equal to 0. So again, anytime we want to maximize or minimize any of these, we just set that derivative equal to 0 and solve. So find the number of units X that produces a maximum revenue if this is our revenue function. So we're just going to take that derivative. We can call it R prime, derivative X, whatever you want to call it. 300 times 2 is 600X minus 0.02 times 3 is 0.06X squared. We set that equal to 0. So setting that equal to 0. Solving that, taking this over to this side. Actually, sorry, take that back. We need to factor out on this one. We need to factor out a 0.06x. So if we do 600 divided by 0.06, what is that, 1,000? 10,000 rather. So that's going to be 10,000 minus, and then 0.06x squared divided by 0.06 is just going to be x. So we set each one of these equal to 0. So x equals 0, x equals 10,000. Well, it's pretty obvious that producing x is not going to maximize our revenue. Sorry, 0. 0 is not going to maximize our revenue because our revenue is going to be 0. So obviously the answer is going to have to be 10,000. If I wanted to find out what that revenue would be, I'd have to plug in 10,000. So I'd do 300 times 10,000 squared minus 0.02 times 10,000 cubed. And it's actually going to be 1 times 10 to the 10th, and that's $1 million. Find the number of, actually that's $10 million. Find the number of units that produces the minimum average cost per unit, C bar, for C equals this. Well, we want to find the average cost per unit and then minimize it. To find the cost per one unit, if this is our total cost, we're going to have to divide this total cost by X. everything gets divided by x. Each one. So I have to divide this by x, and I get 0.002x squared minus 4 plus 100, and then that would be x to the negative 1, because I've got 100 over x. Finding that derivative, multiply 0.004x, the derivative of that is 0, 100 times negative 1 is negative 100, x to the negative 2. Set that equal to 0. Bring this over here, that's really 100 over x squared, that's to the negative 2. On something like this, we have to cross multiply. This is over 1, so we're going to get 0.004x cubed equals 100. And so now I'm going to have to do this all in step. You guys should be able to handle that. We're going to divide 100 by 0.004, get that answer, and now I have to take the cube root of that, and I get 158. So I divided by the 0.004, took the cube root, so x is approximately 158 units, and that's going to minimize our average cost per unit if we produce that many. Find the price per unit P that produces the maximum profit P for a cost function of C equals 200 plus 220x and a demand function of P equals 60 minus x. You have to think about what our profit function is. So our profit function is always going to be our price times x. This is our price. This is the number of items we're selling. This is our total cost. Make sure that you subtract the entire thing. When people miss these, it's usually because they're not distributing that negative. So simplifying this then, I'm going to get negative x squared. 60x minus 20x is 40x. So I'm trying to maximize my profit, so I'm going to have to take that derivative, set it equal to 0. If I set it equal to 0, I can bring this over. So x equals 20. So 20 is going to be the number of units. But that's not what we're trying to find. We're trying to find the price. Well, the price is equal to 60 minus x, and x is 20. Make sure you do that. Plug that back in. So our price should be $40. All right. Next one. That's it. First day. All right. So on your worksheet, make sure you do those kind of things. Make sure that you, when you're finding your maximum revenue, you got to find that derivative, set it equal to 0, and then you should plug it back in and check and make sure that it's going to be, you know, a good answer. Like that, when we saw this 1e10, that means 1 times 10 to the 10th. So that's a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be actually a very large number. Is that really what we want? Yeah, so that is very large. So it's 1, 2, 3, 1, 2, 3, 1, 2, 3. That's going to be 1,000, million, billion. That's $10 billion. Could be a pretty nice day there to make that much a year or whatever it is. All right, so that's that. We'll do the next part.